Hello folks, welcome back. We are mid-project on this standard electric time clock. I've been getting a lot of these in for repair lately. And this one is missing its two bell relays. We can see the whole pattern here. These wires I actually had to replace because the clock had been modified on the back. And these were just lost to time somewhere. This is what they're supposed to look like. This is the slave clock solenoid. The way that they work is this coil is powered by these two terminals up here, and then the actual contacts that drive the load for this one, the slave clocks, and for these two, the bells, go on the bottom terminals. We are going to attempt to make a functional replacement. I've not been able to find any kind of modern open relay like this. There's some safety concerns about this, even though this is a low voltage application. But we're at least going to make something that I think will look reasonable and be plug-in functionally. Next to the original relay here, I have a modern replacement. This is what is available from any number of electronic supply stores. These contacts that are at right angles to the others are the coil, and then these are the switch contacts, which include these terminals. So there's various different configurations of this. All we need is what they call a single pole, single throw, normally open. I wanted to get one that you could see a little bit of the action, so I went with a clear case. This particular one has both normally open and normally closed, so we're not going to use all the terminals. But this modern part is functionally equivalent to this. So what we need to do is adapt it to fit the clock. What I've done is I've mocked up a version of the relay mounting board in my CNC router software. What we're actually looking at here is the bottom of the board. I've drawn the mounting pins for the relay, the mounting holes for the clock and the wiring, and these are all recesses that will allow the wires and hardware to go where they need to go. I wanted to recess the bottom of the relay so I have some room for the pins and for soldering. And what this is going to look like is this right here. So we're going to cut this out and see how it looks. And as a finishing touch, we'll put a little label on it. Here's how this looks connected up. These top two terminals are the coil, and they go to the screws at the top of the module. And then these are the two relay sets for normally open and normally closed. In this case, we want normally open. We don't want power flowing unless we have the relay fire. And so here's our common terminal in the middle, and then here's our normally open terminal. And we can verify that by looking at the inside of the relay itself, where right now you can see it's connected to this outer contact. That's the normally closed one. And when the relay fires, this paddle comes in and makes contact with the front of the three contacts. This is a single pole double throw relay, and so these terminals are just connected internally, and all I need is two of them. I'm just looking for a simple switch. So we to eliminate the EMF that's produced when a coil releases, there is some kind of snubbing device. It's either a diode or resistor, and the original clocks were resistors. And so what I've done at the top here is put a 3.3K resistor inside a piece of heat shrink, but I didn't shrink it, and that looks reasonably authentic to what the original ones did. And so we don't have resistor color code stripes on a piece of plastic, so this I think looks a little better. So that's it. Here's our module. We'll put it in the clock. Here are our two relay modules wired into the clock. and they seem to work very nicely. It's going to come up and fire in a second. I've tuned it for about 6 seconds of firing. You can see the paddle move in a moment here. There it goes. 3, 4, 5, 6. There we go. So these are doing their job. I think they look pretty nice, relatively speaking. They're a little different than the original, but I do like the clear relays, which allows you to see a little bit of what's going on there. So there we go, a nice project to make a part that was missing from the original clock. Thanks for watching.